Okay, this is section 8.5, and in 8.5 we're going to be adding and subtracting rational expressions, and we're going to start with monomials. So we're going to be talking about how to add and subtract monomials. Remember, monomials are one-term items. Okay, so it's going to be one term on the bottom and one term on the bottom. We won't have two terms or anything like that yet. So first thing here as we look, okay, one of the important things, if the denominator is the same, we simply, with addition, you're going to simply combine your like terms in the numerator, okay, and then the denominator stays the same. If it's subtraction, okay, you may have to distribute the negative if there's two terms on the second example, okay. So if the denominator is the same, with subtraction, you'll need to distribute the negative to the denominator. And this should say numerator, excuse me. So this should be numerator here. So as I go here, we're going to cross this guy out, and we're going to say numerator. Of the fraction before you can combine your like terms. If the denominators are not the same, okay, so if the denominators are not the same, then you must find a common denominator first. Then you can add or subtract, okay? So let's look at the first couple examples here. First example, this is in your note packet. A couple of these examples are not in your note packet. You're going to have to write these down as we go through. Okay, so you'll notice that as you see here, I do have common denominators. So what I can do now, because I have common denominators, I can go ahead and just add the top. So as you look here, I have 3x squared and 4. These guys are not like terms, so I cannot actually combine those. But I can write it as 3x squared plus 4 all over 15. Remember, when you add, your denominator stays the same every time, okay? All right, so again, if you have common denominator, we can go ahead and just add our like terms on the top. Example number 2. Here, we have x plus 2y over 20y squared plus x plus 4y over 20y squared. Notice the denominators are exactly the same. So what I can do now is I can combine the tops. I got x plus 2y plus x plus 4y. And that's going to be all over 20y squared. Okay, so now what I can do, since I put them all together, is just combine my like terms on the top. So these guys are like terms. That's 2x. These guys are like terms. That's 6y. And we're going to take it all over 20y squared. Now, the one thing about these types of problems is you have to always check to see, can I factor at the end? So as I look at these two on top, is there something that these guys have in common?
Attention staff.
So if I know I can take something out, I've got to be able to take something out. So I'm going to take out a 2. If I take out a 2, I'm left with an x first and then a 3y second. Because again, 2 divided by 2 is 1. Had an x, didn't take it, still got it. 6 divided by 2 is 3. Had a y, didn't take it, still have it. And then that's going to be over 20y squared. Okay. Now, as you look at this, I can recognize, hey, 2 goes into 20 one time, 2 goes into 2 one time, 2 goes into 20 10 times. So now my final answer, simplified, is going to be x plus 3y all over 10y squared. Okay, so as we look at adding and subtracting, this is one example with like denominators, okay, where you have to simplify at the end. Okay, so what happens if you don't have like denominators? So let's look at this example here. Okay, here's an example of one with denominators that are not the same. Okay, so what I have to figure out here is, what is my common denominator? Between 2u and 3, my common denominator, the least common multiple of 2 and 3 is 6. Okay, so the least common multiple of 2 and 3 is 6. And then one has a u, so they both have to have u's. Okay, this is just like what we talked about yesterday in class when we were working with just the numbers part. So, on the bottom, how do I get from 2u to 6u? Well, I multiply by 3. If I do it on the bottom, I have to do it on the top. So 5 times 3 is 15. On the other side, 3 times what is 6u? Well, I'm going to multiply this guy by a 2u. If I do it on bottom, got to do it on the top. 2 times 2u is 4u. Okay, so I now have common denominators. Now I can combine the top parts. So 15 plus 4u all over 6u. Now, quick question as you look at this. Is there a number that goes into 15 and 4? No, there's not. Do these guys both have u's? No, they don't. And I am officially done. Okay, so I end up 15 plus 4u again, and I can't combine the 15 and the 4 because one has a u and one does not. Okay, another example here. Let's take a look here at this example. All right, 2y over 3 minus 4x over 5x. Okay, so common denominator here. One thing you'll notice, the one thing you can always check to see first, is can I simplify right away? Like, is there anything here I can simplify? Well, no, 2 and 3 don't go into each other. They don't both have y's. But over here, you'll notice that I have an x on the top and an x on the bottom. Let's go ahead, cancel those guys. So now this is 2y over 3 minus 4 over 5. And now it's going to be a little bit easier to figure out my common denominator. So, common denominator between 3 and 5 is 15. Okay, so 3 times what is 15? Well, that's 5. So I'm going to multiply by 5 on the bottom, and of course, if I do it on the bottom, have to do it on the top. So 5 times 2y is 10y. Okay, 5 times what number is 15? Well, that's 5 times 3. So if I do it on the bottom, got to do it on the top, and that's 12. Okay, so now I have common denominators. I can combine these, 10y minus 12 all over 15 again, and I cannot combine 10 and 12 because they're not like terms. But one last thing I got to look for, is there a number that goes into 10 and 12? There is. It's 2, but will 2 cancel with the 15? No, so there's no sense in me trying to simplify. That is my final answer. Okay, so now using these examples, you should be able to complete the examples from 8.5 day 2.